Hello, and welcome to the first in a series of presentations designed to provide a synopsis of the topics covered in microeconomics. My name is Michael, and I will be your guide through this presentation. Our first presentation will explain Jensens Inequality, certainty equivalence, and Pratt measures of risk aversion. So let's begin with the problem. The information. Johann Sebastian von Beethoven is using his brilliant research abilities as a headhunter in a firm which provides personnel service. His yearly income is uncertain and depends on the state of the world, where states of the world are represented by theta subscript k, where k is all natural numbers between 1 and 4 inclusive. Okay, on the first row of our table, we have the states of the world represented by theta subscript k, followed on the second row by the probability associated with each state of the world occurring, and then finally on the last row, the wealth associated with each state of the world. I want to bring your attention to the word uncertain, which is highlighted. Whenever you see the word uncertainty or uncertain, you can understand that it is highly likely that there will be probability involved. The problem is divided into 5 parts. We are going to start with part A. The famous Opera of Milan offers him a fixed wage contract. Problem A. Calculate the minimum fixed wage the opera has to offer to make him accept the offer. Assume that his utility function is given by U of W equals W raised to the power of 1/2 times 1/4. First thing to notice here is that minimum fixed wage is equivalent to the certainty equivalent. What we are trying to find here is the certainty equivalent. You can think of the certainty equivalent as the secure payoff that gives exactly the utility that one would have in expectation from the lottery. So step 1. Read the information that is given and determine the objective. Question A requires the certainty equivalent. For finding certainty equivalent, first find the expected utility of wealth. Solve the inside function, utility of wealth, and then the outside function, expected utility. Step 1. So now we have expanded the table to account for 2 more rows. For the 4th row, utility of wealth, we have simply taken the income or wealth associated with each state of the world and applied our utility function to it so we can understand how much utility Johann will receive from that level of wealth. Referring to the first state of the world in column 2, we take 25,000, apply the square root operator to it, and then multiply it by 1/4. That gives us the utility of wealth. In the 5th row, we multiply utility of wealth by the probability of the state of the world occurring, which is 0.3 for state 1, corresponding to an expected utility of wealth of 11.86. We follow these steps for the remaining 3 states of the world. Problem A, step 2. Calculate the expected utility from summing the probability weighted outcomes. Expected utility of wealth should be equal to sum of probability of each states of the world occurring times the utility of wealth associated with each state of the world occurring. That gives us utility of the certainty equivalent. But we are not interested in the utility of the certainty equivalent. We are interested in the wealth associated with the utility of the certainty equivalent. Therefore, we need to invert the function so that we can have the wealth associated with the utility of the certainty equivalent. And when we do that, we have 49,479.55. Now, answers may vary slightly due to rounding errors. If your solution is significantly different, you may have made a mistake when inverting the function, and we have provided a link that explains how to take the inverse of a function. Now we are on problem B. How big is the risk premium he is willing to pay to avoid the income risk? Problem B, step 1. Objective. Determine the risk premium. Risk premium is equal to the expected wealth minus the certainty equivalent. Expected wealth is an expectation of the different states of the world occurring. Keep in mind that expected wealth will not be achieved. Rather, one of the states of the world will be achieved. So the expected wealth is equal to the sum of probability weighted outcomes, or states of the world, multiplied by the wealth associated with each state of the world. And expected wealth is 51,500. Now if we subtract the certainty equivalent, remembering that the certainty equivalent was 49,479.55, we have a risk premium of 2,000 20.45. Okay, back to the problem. Part C. Is Johann Sebastian von Beethoven risk averse? A person that is risk averse, when given a choice between two alternatives with the same expected payoff, will choose the alternative that is less risky. It's important to remember that simply because a person avoids a lottery, it does not mean that a person is risk averse. Graphically, an agent's risk preference can be inferred from the shape of the utility function. Concave for a risk-averse agent, suggesting that the marginal utility they receive from an increase in wealth is decreasing. Linear for a risk-neutral agent, suggesting that the marginal utility they receive from an increase in wealth is constant. And convex for a risk-loving agent, suggesting that the marginal utility they receive from an increase in wealth is increasing. Problem C, Step 1. Johann Sebastian von Beethoven is risk-averse. The shape of his utility function is concave. That is to say, it is decreasing at a decreasing rate. Problem D. Compute his Pratt measure of absolute and relative risk aversion. Absolute risk aversion is equal to the second derivative of the utility function divided by the first derivative of the utility function times -1. Relative risk aversion is equal to the second derivative of the utility function divided by the first derivative of the utility function times -1 and times wealth, or W. So the only difference between absolute and relative risk aversion is that you multiply by W, which causes the W in the denominator to drop out. To summarize, the greater the person's risk aversion, the greater their Pratt measure of risk aversion is. Okay, the problem. Now we're on part E. Give a graphical interpretation of problems A and B. Illustrate Jensens inequality. Jensens inequality states that the utility of expected wealth is greater than or equal to the expected utility of wealth. So let's start our graph out with a utility curve. On the y-axis we have utility, and on the x-axis we have wealth. The curve illustrates utility as a function of wealth. Point A is the utility of expected wealth, which corresponds with the expected wealth on the x-axis. Point B is the expected utility of wealth, which corresponds with the certainty equivalent on the x-axis. So we have expected wealth as point C corresponding with point A, utility from expected wealth. So we have point D, certainty equivalent, corresponding with point B, which is the expected utility of wealth. Notice the space between C and D. This is the risk premium. So basically what we can understand is that point C is the expected level of wealth. On average, Johann will receive this level of wealth. However, because he is risk averse, Johann would prefer to pay a premium so long as Johann is guaranteed the certainty equivalent. So Johann is risk averse, so much so that Johann would rather receive 49,000 plus and pay 2,000 plus in risk premium, just so that Johann does not have to take a chance on the income he receives. Problem E. This illustrates what we have already reviewed. You can read that on your own and look at the graph if you like. The last part of our problem. What is the economic meaning of? Economic meaning is often painfully obvious. However, contemplation and application afford a thorough understanding. A greater degree of risk aversion will correspond to a higher risk premium and a more pronounced Jensens inequality. It has been my experience to fully appreciate this economic meaning. But it helps for an individual to contemplate how Jensens inequality and varying degrees of risk aversion apply to real-life situations. Alright, that is all for today. Thank you for your time and patience, and I hope that this presentation has been helpful. Have a nice day.